Composite armor is an advanced protective technology and it is combined of multiple materials such as ceramic, polymers and high-performance fibers. It is to achieve superior ballistic resistance and energy absorption. And all the materials combined were in specific ratios to balance protection, weight and durability. Ceramics like alumina or silicon carbide make up 30 to 70% of the armor. It serves as the hard strike face to break projectiles. High-performance fibers such as UHM WPE, ultra-high molecular weight polyethylene or Kevlar form 30 to 50% of the systems. It is for absorbing and dispersing impact energy. Next, a polymer matrix make up around 5 to 15% that bind the layers together, while adhesive and coatings make up around 1 to 5% to enhance durability and environmental resistance. This ratio might vary based on the threat level and design requirement. This is designed to overcome the drawbacks of traditional steel armor. Composite armor provides superior protection against projectiles, shrapnel and explosions while being considerably lighter and more adaptable. Its layered construction harnesses to distinct advantages of various materials, achieving an ideal combination of strength, flexibility and resilience for use in military, law enforcement and civilian contexts. For background and history, composite materials is a combination of two or more different materials to enhance strength, durability, and flexibility of the component. They have been used for thousands of years since the ancients. For example, Mesopotamia mixed straw with mud bricks, and the Egyptians used resin-coated linen for boats. Other than that, the Romans developed reinforced concrete, while the Mongols crafted powerful composite bows. And advancements like fiberglass, carbon fiber, and Kevlar was found in the 20th century to revolutionize aerospace, automotive, and military applications. Yet, in today's life, cutting-edge composite, including nanomaterials, biodegradable options, and smart material that can self-heal. And these materials are widely used in industries like construction, sports, space exploration, continuously evolving for better performance. Chobham armor is one of the composite armor that was introduced in the 60s. It is commonly used in vehicle armor such as tank. The armor is laminated with ceramic, steel and titanium sandwiched together between ballistic nylon. It is proven to be highly effective in defeating heat rounds. Even so, it is heavy and expensive to be used on a lighter military transportation.
Chobham armor is a form of composite armor that consists of a layer of ceramic sandwiched between two plates of steel armor and is primarily used in military vehicles to enhance protection against modern threats. So the first successful implementation is Chobham armor is used on main battle tanks such as the Abrams or M1 Abrams tank, where it has been proven to be highly effective in defeating high explosive anti-tank or heat rounds. So the Abrams uses a variation of Chobham which includes a layer of depleted uranium. So the combination of ceramic, metal, and uranium gives Abrams one of the highest protection levels in the world. The Abrams armor is concentrated on critical areas such as the turret and frontal arc where the tank is most vulnerable to enemy fire. Another application of Chobham armor is in the Challenger 2 tank, which offers a protection against a variety of threats including kinetic energy projectiles and explosive rounds. So the Challenger 2 tank uses ceramic layers which are more resistant to high-velocity impacts than traditional steel armor. In addition to its ceramic layers, the Challenger 2's armor incorporates spaced armor, which adds an extra layer of protection by creating gaps between the main body and external plates. So these gaps absorb the energy from projectiles, reducing the likelihood of penetration.
I will now talk about the innovations of composite in military. One of them is Chobham. Although it was first developed in the 1960s, it still remains as one of the most effective composite armor systems used today. It involves a combination of advanced ceramics, metals, and plastic layers, and offers exceptional protection against both kinetic energy penetrators and shaped charges. As technology advances, future innovations in composite armor are likely to draw from the foundational principles of Chobham due to its core design, while incorporating new materials, such as advanced ceramic and nanomaterials, metal matrix composites, layered hybrid armor system, such as in the picture below, and its integration with active protective systems, which are mostly used in tanks.
There are many advantages if we use composite materials in armor, such as lightweight. Composite materials are much lighter compared to traditional steel armor. which can provide more fuel-efficient vehicles. This means it can improve mobility and agility of the vehicle to avoid ballistic threat rather than protect itself against them. Secondly, composite materials in armor have multi-layered design, in which it can reduce mass, exceptional performance against missiles, and multifunctionality. Each layer can serve a specific purpose, and their combinations can contribute to a multifunctional role. Next, composite materials can provide protection for the armor by absorbing large amount of kinetic energy during the impact of heat or high explosive anti-tank projectile. In this way, it can reduce the likelihood from penetrating the armor. Lastly, composite armor's layer construction allows for increased flexibility, conforming to the outline of the wearer's body or the vehicle's shape. This flexibility enhances comfort and responsive in combat situations, enabling soldiers and personnel to move more freely without compromising their protection.
Assalamualaikum. Now I present the challenges and limitations in using composite as the materials for armor. One of them is manufacturing complexity. During the steps, two or more materials are carefully aligned and bonded together to enhance the material's strength and resistance. One of the common methods is vacuum bagging, as shown in the figure below, which ensure uniformity and effective stress distribution across the layers. To create a composite layer, the temperature and pressure conditions during processing are very important because each layer requires precise temperature and pressure during curing to achieve optimal adhesion and strength. Maintaining these conditions is essential as even slight variations can alter the armor's properties. To ensure the armors to perform effectively, layer adhesion is essential. However, some challenges may occur during these steps, particularly in surface preparation. Effective bonding requires meticulous cleaning and treatment of surfaces to ensure optimal adhesion. Any contamination or inconsistency can break the bond, which led to delamination and reduced performance of the composite. Besides that, extensive testing is necessary to validate the adhesion quality. This includes evaluating the bond strength under various conditions, which can be time-consuming and costing, which will take more time and more money to produce a high-quality composite. This is the diagram of delamination that occurs due to the fast processing of composite materials.
And now moving on to future trends. First one, shape memory composite armor. One of the most promising applications of shape memory composites in armor technology is adaptive impact resistance. Traditional armor materials are often rigid, which can limit movement and comfort. However, by utilizing shape memory composites, armor can remain flexible during normal wear and stiffen upon impact. This capability significantly enhances comfort for soldiers and law enforcement officers while maintaining high levels of protection. For instance, body armor vests with SMP layers can harden instantly when struck by a projectile, dispersing the force more effectively than conventional materials. Second one, hybrid composites. Combining traditional fibers such as aramid carbon and or ultra high molecular weight polyethylene with ceramics or metallic layers in a hybrid configuration is a growing trend. This approach leverages the high hardness of ceramics for initial impact resistance and the toughness of fibers for energy absorption. Then the final one, advanced nanotechnology integration. Nanotechnology is revolutionizing the field of composite armors by enabling the creation of material with superior strength to weight ratios and enhanced energy dissipation properties. At the forefront of this revolution is the integration of nanostructured reinforcements such as carbon nanotubes, graphene, and MXEs into composite matrices. These materials, owing to their exceptional mechanical and thermal properties, can dramatically improve the armor's resistance to high velocity impacts while contributing minimal additional weight. And now for the conclusion. In the final analysis, composite materials in armor offer a balance of lightweight protection, durability, and versatility, making them a critical advancement in modern defense technology. By combining materials such as ceramics, polymers, and fiber reinforced composites, these armors achieve superior ballistic resistance while reducing weight compared to traditional metals. This results in enhanced mobility for soldiers and improved performance in military vehicles. Additionally, ongoing research continues to refine composite armor, increasing its effectiveness against revolving threats. As technology advances, composite materials will play an increasingly vital role in the future of protective systems across military and civilian applications.